Good morning, superhumans. Yes, we're live. And this is going to be a really cool one today because I have a couple of special guests coming on. As you would know, I've been working with my friend Chris for many years on various projects related to assistive technology. Chris has Duchenne muscular dystrophy, so we've worked on projects related to hacking his wheelchair and using home automation technology to help him to do things, which is, it's a really cool and fun thing to do and very satisfying. And as part of the process of doing our wheelchair projects, we ended up getting in touch with a couple of brothers from Canada, Daniel and Michael Coe, who have been doing some really cool projects as well. So today on the live stream, we have Daniel and Michael Coe coming on to join us, and we're going to talk about the really cool things that Michael has been doing to modify Daniel's wheelchair to give it voice control and do all sorts of fun things like that. So I'm going to bring them on right now, and we're going to say good morning. Good morning to Michael and Daniel.
Good morning, everyone. My name's Michael, and this is my brother Daniel.
Hi.
It's good to meet you, John.
Yeah, it's fantastic. So we've been in contact via Facebook for, I think it must be about a year now. We've been chatting about different things. It was some time before, it was while Chris and I were working on the wheelchair controller before LCA 2020. So it would have been sort of mid to late 2019, I think, we started chatting.
Yeah.
Yeah. And it came about because we were looking at wheelchair control systems, and we came across an article in, I think it was the University of British Columbia News, which did some coverage about the project that you've done for Daniel's wheelchair and the voice control system that you built for it. Oh, and also I should mention for the audience, if you have a voice assistant that is within range of you right now, you should probably hit that mute button on the voice assistant. I'm just doing it myself because we're going to be talking about voice assistants today, and the things that we say might activate things in your house. So best to disable that if it's nearby your computer. So the project that I first saw you working on, Michael, was the voice control system for Daniel's wheelchair.
Right.
And maybe what we could do to start with is you can just explain a little bit about the background of muscular dystrophy, because many people that are viewing this may not know what it is and how it affects the body. So a little explanation of Daniel and the situation that he's in.
Right, for sure. So muscular dystrophy, sorry, and I've been adjusting the camera here and there to get the right angle. But muscular dystrophy is a condition that progressively weakens the muscles in the body. So Daniel was born with the condition, and when he was a young child, it's kind of awkward to say it because he's older than me, but he was young. He used to be able to walk around, move, play basketball. I think playing soccer was one of your favorite sports too. But as time went on, he began to slowly lose muscle functionality in his body. And as a result, he wasn't able to start walking. He wasn't able to move his arms or legs. And he's currently 29. And over the past years, year by year, he wasn't able to do a lot of the things that he used to be able to do. So muscular dystrophy overall is a condition that slowly takes away the movements that one can have and the muscle functionalities of one.
Yeah, and that affects all sorts of different aspects of your body. So when people first hear about muscular dystrophy and they think of muscle weakening, the obvious things are things like balance and the ability to walk and use your hands, but it also affects, so much of your body is muscular structure. So it affects your ability to breathe and to swallow and all sorts of different things. It's something that very much affects everything about your life.
Yeah, definitely. It's a whole different kind of lifestyle, I guess, with muscular dystrophy.
Yeah. And early on, so I've only known you for about a year, but my understanding is that some time ago, Daniel used to use voice systems. Did you use Alexa or Google Home or something like that?
Yeah, we used to use Google Home for Daniel to interact with different things in his room, especially his phone. But as time went on, Daniel had to get a tracheostomy surgery, which is a surgery that affects his vocal cords. So for us, it's easy for us to breathe in and out of our mouths, but for Daniel, because of his condition, his lungs were weakened. And as a result, we needed a shorter pathway to his lungs. And so they cut a hole in his trachea. And you kind of see that on the screen too over here. But because of this surgery, he couldn't speak like he normally did before. And those voice recognition systems had a hard time understanding what he was saying. So we used to be able to use Google Home and Alexa before, but not after his surgery.
Yeah. So when you were still using those systems, what sort of control did you have linked up to it? Were there devices around the house like lights and things that you could control?
Yeah, lights and mostly his phone. Daniel goes on his phone a lot, and he could use it to either call us or just watch videos on his phone as well.
Okay. So it was a way of getting just direct control over the phone itself rather than using like in Chris's case, he often uses a Bluetooth link from his wheelchair controller to the phone.
Oh,
so
I see.
he can use a Hall effect joystick on the wheelchair, which is Bluetooth linked. And so that gives him some control. But in Daniel's case, he needed to use voice to interact with the phone.
Yeah.
Yeah. Okay. Cool. And so the thing that makes your project so interesting, I think, is that after Daniel's tracheotomy, he could no longer use those traditional voice. It's funny when I say traditional, as if, everybody uses voice control systems. We're used to just talking to things and having them respond. It just shows that we're living in the future. So he couldn't use those anymore. And I think that was because of the duration or the length of messages that he would have to say. Is that right?
Yeah, so Daniel right now, after his tracheostomy surgery, he's good at saying hi. I don't know if you said hi to the audience. You want to say hi real quick?
Hi.
Yeah. Okay, Daniel said hi. But long sentences are really hard for him to speak because of his surgery. And like simple words with simple syllables like 1, 2, hi, bye, he can say easily, but not long sentences.
Like,
Yeah. Yep. Cool. So one of the techniques that is used in traditional voice control systems is they use a thing called a wake word, so that they are not listening constantly to everything you say. They're just looking for a specific word. I mean, you obviously already know this. I'm partly explaining this for the audience as well. So a system like Alexa is not listening and deciphering every single word you say constantly throughout the day. All it's doing is being in a passive mode where it's waiting for a wake word, and then when it detects the wake word, it then starts processing the audio associated with it.
Right, exactly.
And so in your particular case, you couldn't use a wake word followed by a command because that's too much to say in one go. You have to cut it down to little chunks.
Yeah.
So do you use any form of wake word, or do you just listen constantly, or how do you handle that situation?
Yeah, so for Daniel, he is able to say small syllables one after another in a relatively short time frame. So I guess this is kind of infringing on the wheelchair project that we'll share about later. But in that case, I was able to train a custom wake word called Ava. And how Daniel would execute commands is he would call the wake word Ava, and then I would set a timer for like maybe 1 or 2 seconds to pause, and then start recording his next word, which would be the command. So it would go something like Ava, and then go. And during that time frame, I would have a short pause in between for him to catch his breath.
Oh, cool. Okay, so it's really tuned to the way that he can interact with it.
Right. Yeah. Exactly.
Yeah. Fantastic. So one thing that I'm really curious about is how you implemented the voice recognition system. And so I think you're using machine learning for that.
Yes. Yeah.
Yeah.
Um,
And so you had this problem. You knew that you wanted to build a custom voice control system.
yeah.
And how did you go about solving that problem? Like, I'm really curious. If I had that problem and someone said to me, I want you to build a custom voice assistant,
Right.
I don't think I would even know where to start. Like, how did you go about solving that problem?
I didn't know where to start either, to be honest, John. But for me, oh yeah. 조금 기다릴 수 있겠어. So sometimes I just needs a little bit of help with things here and there. So, but
yeah, that's fine.
Yeah, but for me, I didn't really know anything about computer science, neural networks, or machine learning to begin with, and all I really did was go on the internet and search up how speech recognition worked and the training programs that would be used with it. So, in our case for Daniel, we use something called TensorFlow, and it uses something called convolutional neural networks, and it's essentially, you can kind of think of it as like the human brain in a way. So you train a neural network to recognize certain patterns, and in Daniel's case, I recorded him saying a bunch of things like hi, on, off, and I trained the neural network to kind of recognize his way or his pattern of speaking certain words. And through that, it was able to recognize, let's say, after it trained on Daniel's data, he says a word like on, then the neural network is able to recognize that, okay, with this kind of microphone input, it corresponds to this certain word that I've been trained to.
Okay, great. So in order to do that training, typically when you're training a neural network, you need to collect a lot of tagged data, so known input that you can use for training. Did Daniel have to repeat those words over and over again to build the material for training?
Yeah, so I remember one day when we were... 형아, 아빠 필요해? 조금만 기다릴 수 있겠어? 아빠 지금 가져. 아빠... 오케이.
가지.
Okay. Right back. Sorry, John. Daniel's just gonna need a little bit of help with something. Can we be right back?
Yeah, sure. No worries.
Sorry.
That's okay. Do you want me to take you off the live stream for a little while?
Yeah, that would be great.
Okay.
Thank you.
No worries. Just send me a message or something when you want to get back on.
Yeah, for sure. Thank you.
Cool. See ya. Okay. So, I've got to move myself around because I've rearranged things. The camera is in a bit of a strange position at the moment, and I'm having trouble sitting. I'm actually sitting really off to the side from my computer in order to get in front of the camera. And that is for a reason that you might see a little bit later on in the live stream. So let's see in the meantime if we've got questions. So sentence length. So there was a question from Sion, Unexpected Maker. Will longer sentences improve over time? If that question is about will Daniel have more ability to say longer sentences over time, then the answer is probably no. And I'm answering on their behalf at the moment, but we can check with Michael and Daniel when they come back. Muscular dystrophy is a degenerative disease, which means that it doesn't get better. It only ever it stays the same or gets worse, which means that things like degeneration of muscles continues over time, and then the ability to do things like inhale and exhale decrease, and then as that decreases, the ability to speak decreases as well. So one of the effects is a decrease in the ability to speak, either project or to say long sentences over time. So I hear Pancake Legend said both OK Google and Hey Google are just awful to say. Yeah, there's, yeah, okay, so, yeah, so Sion said, yeah, meaning after the operation. Was the operation itself the cause of contributing factor of the shorter sentences? Yeah, that's a very good question. I will ask about that. So one of the issues with breathing, just speaking from the point of view of what I've seen with Chris. So Chris is using a ventilator. He hasn't had the tracheostomy. So he has a ventilator that covers his nose, and so the ventilator is running 24/7, and it is on a certain breathing cycle. And what that means is that he doesn't have control over when he inhales and when he exhales. So for you and I, what happens is when we're speaking, like me speaking right now, I will inhale and then I will hold that breath, and then I can say a fairly long sentence over a period of time because I'm very slowly exhaling as I'm speaking, and I can time the point at which I'm going to pause speaking and then inhale again. When using a ventilator, you don't have that control. You can only speak on the exhale portion of the breath, and that cycle is dictated by the ventilator, which means that, oh, it looks like they might be just about ready to come back. Yes, I can see on the video. So, Michael, just wave in front of the camera if you're okay to be added back to the live stream, and I will do that when you're ready. So what happens is that it's necessary to time the words that you say to the breathing of the ventilator. And that means doing things like saying a couple of words and then a pause, and then a couple of words and then a pause. And that pause can really mess up speech recognition systems because they think that you've finished speaking. So you start by, you might say something like, use a wake word, and then the start of a command to a voice recognition system. And then there is a pause because the ventilator forces that little pause in the breath cycle. And then the speech recognition system thinks that you've stopped speaking and it tries to interpret it, but it's an incomplete command. So that can be very difficult. Oh, Michael, yep, wave. Okay, I will bring you back in. Fantastic. Hey, welcome back. Your microphone is muted at the moment. So I think you'll just have to, yep, that's it.
Yeah, sorry about that, guys.
Fantastic.
Sometimes Daniel just needs a little bit of help here and there, just getting in position and with suction, but we're back. Yep,
that's no worries. Okay, so there were a couple of questions in the chat. I don't know whether you can still hear me while you're off stream then. And so one of the questions from Sion was in relation to Daniel's ability to say longer sentences or utterances, and whether that is a direct result of the tracheostomy or whether that was something that was happening before that as well.
That's a really good question. Before Daniel could speak long sentences, what Daniel likes to do is talk a lot during our family discussions, but ever since he got the tracheostomy, he could only start saying syllables. So that was from the tracheostomy itself.
Okay.
Yeah. What's the longest word you could say?
I don't know.
I don't know is the longest word you could say.
Oh, that was pretty long. Yeah, that was saying 3 words in one go.
Yeah.
Yeah, cool.
Anything longer than that needs to take a bit of a breather break in between.
Yeah, sure. Okay, so I don't really have a structured way I'm asking these questions of you. So this might seem like I'm jumping around a little bit, but I'm really interested to learn a bit more about this voice control system. And then ultimately what we're going to do is get on to what you're using it for, right, and the wheelchair and all of that stuff. That's cool. But the voice control system, so there are, with a machine learning system, there are a couple of phases that you have to go through. There is the training that we've been talking about. So you collect a whole lot of utterances and then you teach the model that this is a particular word or this is a different word, and then it gives you the output to say what it has detected.
Right.
And that process you do for training, and then once you've trained the model, you run it and actually get it to detect words. So they're two very distinct phases.
Right.
And could you explain a little bit about the equipment that you're running it on? So did you do all of the training with, for example, a laptop and a microphone, and then move it over to another device for running it? Or what sort of equipment are you using for this?
Right, for sure. So initially, to train the data set with the neural network, I used my laptop, and it's not a very fancy or powerful laptop, because I think for neural networks, Daniel's data set of words isn't very big. Maybe about 10 words he uses in total. But for larger data sets where you have more people, you definitely need a larger GPU and CPU computation power, and it'll go on for a lot longer. But for Daniel's case, I found that my laptop of 8 gigabytes RAM was good enough to train its data in a relatively quick time. The thing is, I can't put this laptop on Daniel's wheelchair or anything. So for processing, I found that a Raspberry Pi was powerful enough to take in a microphone input and process that neural network with his audio file whenever he spoke.
Yeah, great.
Too powerful for processing, but for training, it takes a bit more time and effort.
Yeah, cool. So yeah, that's exactly the experience so there's another project that I helped out with a year or two ago, which was the Dingo Car project.
Right.
Which was basically taking a remote control car, putting a Raspberry Pi on it with a camera, and training it to go around a track, which was sticky tape on the floor. So you drive it around with the remote control in order to acquire the data. And then once you've trained it, you can get it to run by itself. So in that particular case, so that was a system that was a project that was spearheaded by my friend Andy, who's here in the chat, I believe.
Oh.
And so in that particular case, what it did was use either a laptop or a cloud-based service for the training. And then once the model was trained, the model would be transferred to a Raspberry Pi, and it would process the video stream coming from the camera on the car in real time on the Pi. So,
I see.
Yeah, and that worked really remarkably well. So even with something like a Raspberry Pi, which is not a particularly powerful device, you can apply a machine learning system and have it work quite effectively. So once you had done all of this training and you had had the system recognizing different words that Daniel would say, you have it running on a Raspberry Pi, and then how do you have the Pi attached to the chair, and how do you power it? One of the interesting questions that comes up often when I start talking to people about this sort of thing is power requirements. And one thing that a lot of people, once you point it out, it's obvious, but a lot of people don't think about the power requirements of a wheelchair. And a wheelchair has a huge battery pack in it. It's got lots of power to spare. So doing something like powering a Raspberry Pi, it wouldn't even notice it.
For sure.
So could you explain a little bit about what you then did to attach all of this to the chair and allow it to be controlled?
Yep, I actually have the model right over here, if that's okay to show on live stream.
Yeah, actually, what I might do, this would be a very good time. I'm going to show a little 1-minute video clip which shows Daniel controlling the chair using voice commands. So I'll play this now, and then we'll come back and have a look at the model.
Yeah, sounds good.
Ava L. Ava S.
Let's try turning to the right.
Ava R.
Nice.
Ava S.
Nice. We did it.
We did it.
I've watched that. I think I must have watched that video like 20 or 30 times, and I still love seeing it.
Thank you. Yeah.
Yeah.
Yeah, so you've got a device that is attached to the joystick of the wheelchair. That so you're physically moving the joystick on the wheelchair in order to make it move.
Yeah. So what we're doing is we're controlling the joystick direction to move in left, right, forward, back. And that was probably because I did that project back in my second year, or started in my second year, continued it on in my third and fourth. And I wasn't quite sure if I could dig into the electronics of Daniel's wheelchair, because if something pops, which it very well could, it's a pretty expensive wheelchair. So I went on a bit of a safer route, and I decided to control the joystick itself to move the wheelchair. And it had, had its pros and cons too.
Yeah, okay. One thing that I noticed, I think most people who watch that video would not have noticed it, but because I've spent time playing around with wheelchair control systems, there is one very specific thing I noticed, and that is that you did a left turn, stopped, and then did a right turn and stopped, and did not end up in the same place. So so it was driving one of the wheels a little bit faster than the other. So it was kind of doing a bit of a crab walk sideways.
Right.
And my guess is that that is just because of the physical alignment of the joystick and the way that it's being driven. And it was probably slightly out of alignment, and it might have been like very slightly inclined forward or backwards as it was moving sideways, which was causing that effect.
Those are really good because the joystick manipulation, it wasn't completely perfect, and oftentimes it's like a slight misalignment could lead to a misplacement like that. Yeah.
So how, I suppose the $1 million question here is, how useful has this been for Daniel in terms of being able to control his chair? I mean, this sort of project is fantastic as a demo, but is it practical? Like, how useful has it been?
As at least inside the house, like Daniel has been able to move around in his wheelchair in very open spaces, but let's say like really tight corridors or really tight spaces, it could be a bit difficult for him due to the nature of delay and voice control, as well as the misalignment in the system. But I do think the most important part of this project, although it's not perfect, it was to show that there could be a way to fight back against accessibility challenges, which is why we kind of started it in the first place as well, just to show a little bit about that.
Yeah, well, it's hugely inspiring. I love this project so much. So, yeah. And the thing is that once you have got this you've got it to this point and you've got some control over the system. So you've really solved a couple of really tricky problems here. One is the problem of the voice control side of it. So you've done that. And the other part is control over the movement of the chair. And once you've got those two fundamental things working, there are many, many other aspects that you can bring into it in order to improve the practicality of it, I suppose. For example, with the addition of, say, ultrasonic range finders, you could add anti-collision to the chair so that Daniel could give a direction to be moving down a corridor, and the chair would move down the center of the corridor without bumping into the walls, even if it wasn't perfectly aligned. So there are all sorts of things like that that can be added onto it once you've solved those fundamental problems. So the fact that you now have this base platform that you can experiment with and extend is a really big achievement.
Yeah, and I know that for a fact there's a lot of improvements that need to be made to it, but it is something that I do want to see happen in like my future, and not just for people like Daniel, but for other people as well.
Yeah.
Speaking of which, I do have the physical model here.
Oh yeah, I'd love to see this.
Maybe I'll bring it closer to the camera.
Hang on, I will. I'll see if I can make you full screen.
Okay.
Let's see. Solo. Here we go. Yep.
Okay, awesome. So, wow, Daniel's full screen too. Uh, but the model of how we control the joystick is, and also to answer the question about mounting everything onto the wheelchair as well, is I 3D printed and designed a little mounting system that goes onto the joystick controller. And it's a bit hard to visualize because I don't have the joystick here with me, but essentially this will wrap around the front part of the joystick where there's usually an LED display and some speed controls and the power button up at the front of the wheelchair. And then the back part of this contraption is a little hole that the joystick will fit through. And this wraps around the joystick. And we have two stepper motors here, which will manipulate the direction that the joystick will move into, whether that's going forwards to the back, or if we're going to the left and right, one stepper motor will push and one will pull. So we get the stepper motor to move in the leftwards or the rightwards direction. And for the Raspberry Pi that's used to control the voice recognition system, it's just attached right below. And there's a small LiPo battery pack of 3.3 volts that can power the system. Sorry, 3.7 volts that will power the Raspberry Pi. But yeah, everything was printed and designed in PLA. A lot of trial and error to fit everything onto the wheelchair. At the end of the day, we got something that was able to move the joystick in the desired direction that Daniel wanted to go.
That's a very clever design. The control over the joystick, so you're only using two steppers and yet you are achieving XY control.
Yeah.
So I suppose the closest analogy I can think of is that this is a little bit like a Delta 3D printer that uses three arms to control the print head in 3 dimensions, so X, Y, Z axis. And so by using those two, you can move the joystick to any position in the X and Y axis. Yeah,
for sure. And I actually started off with one stepper motor at first to test the forward and back. And I kind of spent a couple of days thinking about how we can get 2D motion in the X and Y planes. But yeah, the answer ended up being a lot simpler than what I originally thought it was going to be, which is sometimes the true in most engineering cases as well. So it was a really good learning lesson.
Yes. Yeah, often the biggest challenge of engineering is to simplify. It's not to make things more complicated. Yeah.
But yeah, this is a little 3D print joystick controller that was used for Daniel's wheelchair.
Oh, that's great. So did you have to iterate through a few different versions of that, like print different versions and get the fit to work properly?
Yeah, totally. I mean, the first time I printed it, nothing fit at all. And I think I went through about 5 design iterations on Onshape, just changing little parameters here and there, trying new things out to finally get it to fit the way it does right now, which is a pretty tight and close fit.
Yeah.
But the design cycle is always something that's pretty rough.
Yeah. So on Daniel's wheelchair, I didn't actually pay attention to this part in the video, but my assumption is that what he has is the joystick on the front and then there will be an attendant control on the back. Is that the case on this chair?
An attendant control as in?
Like a second joystick on the back of the chair?
Yeah.
Yes. So it doesn't matter that you put this mechanism over the main joystick because that's not normally used anyway. You can leave the assembly on there and it's not going to get in the way of controlling the chair manually from the rear joystick or anything else.
Right. Yeah.
Yeah. Cool. Okay.
Daniel,
all right.
Your thoughts on the wheelchair project?
I'm able to drive by myself.
Yeah, so Daniel said he's able to drive by himself, which was pretty big because up until that video that we all saw, it had been 3 years since Daniel went on the wheelchair and was able to control it by himself. So yeah, that was a pretty touching moment for the both of us.
Yeah, it would be. Yeah, a real feeling of being able to control yourself and not be at the not have others controlling for you.
Right.
That psychologically, that is a really important thing.
Yeah.
Yeah. Cool. Okay, so there are a couple of other questions. There was a question that I think we've answered obliquely already. So David Rowe said, is the voice system in-house or using remote cloud systems? So you're doing everything yourself. You're not relying on an external system for running any of the machine learning system.
Yeah. So it's all in-house.
Yeah.
Yeah.
Okay. And there was a question from Andy who said, do you see other uses for machine learning? For example, using machine learning to help drive the wheelchair and not crash into things, such as handle wheelchair motor misalignment or collision avoidance and those sorts of things.
Mm-hmm. Yeah, I see a lot of potential for machine learning to be used in accessibility sectors. I think especially with the technology that we have right now, I think it's very possible to solve a lot of the challenges that we face in this area, which is kind of why we started on this project as well, to kind of get that rolling. But for sure, with obstacle avoidance or just making sure that we're a certain distance away from the wall, machine learning can definitely be used for that as well. And those are some really great ideas.
Yeah, cool. So, excuse me. So, are there other things around the house that you use Ava to control, or is it just the chair?
It is. We can actually control Daniel's computer using Ava. He's able to manipulate the cursor, and there's a Python script that we have being used for that. He can also control the lights, but the main part was the wheelchair itself, and that's what we spent a lot of time on. Yeah.
Okay. So in your house, do you have any home automation technology? Like, oh, sorry.
Yeah.
I'll just wait for Daniel.
Okay. Yeah. Okay, sounds good. Sometimes for Daniel, he likes taking a lot of naps here and there, and I think he's getting a little bit on the resting side, and he's been with us like as much as he can. But John, I'm really happy to stick around after and keep answering any questions or keep talking about the project.
Sure.
Yeah, but Daniel might need to go in about maybe 5 minutes per se.
Yeah.
Sure. Well, in that case, just before Daniel goes, perhaps we can do that little test that we were planning earlier. So this is what I was getting to with this line of questioning. With the voice control system, now that you can recognize different things that Daniel can say, that can then be sent off to control other things. So for the benefit of the audience, yesterday, Michael and I very quickly did a quick little mashup where we took the system running at their house and my home automation system and linked them together via MQTT and a few other things. So now let's see if Daniel can control the lights in my lab. Let's just see if this works.
All right, Daniel, are you ready?
Yeah.
All right. So I currently have a system set up on my end at the place where Daniel will say 1 or 2, and 1 should turn on the lights and 2 should turn off the lights. And also it will control the computer to move the cursor in the direction to put those into action. So let's give it a try. Daniel, do you want to say 1?
1.
Yes, it worked. I was sitting here in the dark until now. It looked kind of bright before because the camera was compensating for it, but the lights have been off this whole time. Thanks, Daniel.
Okay, since we turned the lights on, we got to turn them off too, right?
2.
Right. Oh, wait. Let me run the script. Okay. Whenever you're ready, in 3, 2, 1.
2.
Yeah, that worked. Awesome. So there was a bit of lag there, as we could see on the video, from the time that Daniel said to the time my lights turned off. But if you stop and think about the chain of events that is happening to cause that to actually work at all, that is amazing. So Daniel is there in Canada, I'm in Australia, and the voice recognition system was detecting his voice, sending a command to the computer, which was connecting to a server in California, which was then talking via MQTT back to my house, which was talking to my switchboard and turning my lights on and off.
Yeah,
So that's pretty amazing.
that Daniel turned off the lights on the other side of the world, just using this kind of technology.
That's right. So now let's try something else. So back behind, we actually don't know if this is properly going to work yet. This could be a disaster. Now, I have a big red emergency stop button right here, ready to go. I'm going to have my hand on it. But let's see if Daniel can control this robotic water cannon behind me.
Okay, so Daniel, I didn't tell you about this yesterday when we were talking, but that right over there is a water cannon. You see the yellow equipment? Yeah, that's a water cannon. And we're going to try issuing some commands. It's going to be the same command. So you're going to say 1, and then you're going to say 2 afterwards. Okay?
Yeah.
All right. So let me just set it up. All right. Whenever you're ready, go for 1.
1.
Oh, do you want to try saying that again? It was a bit too quick. Okay.
1.
Oh, wait. Give me like 3 seconds.
He's too anxious.
1.
Yeah, it's moving.
Oh my gosh. Wow.
Hey, Daniel, you just moved a robot on the other side of the world.
That's pretty awesome. Fist bump. Okay. Are we able
now
to
you can make it go down again.
Okay. So if you moved it up, we should be able to move it back down. So, yeah, whenever you're ready.
2.
There it goes.
Yep.
It'll get to the bottom and stop. There it goes. Yes.
Wow, that's pretty awesome, Daniel.
Yeah.
Yeah.
Alright.
Remote control robot.
You control the robot on the other side of the world.
Alright.
Yeah, that's so cool. All right. So it was fantastic to meet you, Daniel. Thanks for coming on the live stream.
Okay. See you.
All right. So, Michael, I will chat to you again in a minute. Do you want me to take you off the stream and then add you back once you're ready?
I'm just going to set Daniel up, and then I'll join the stream right after. Yeah.
Okay, fantastic. All right, I'll see you again in a minute.
Thank
Oops, I cut them off just a second too early. Okay, that little demo with linking those things together was something that the idea only occurred to me yesterday afternoon, and I messaged Michael on Facebook and said, hey, how about we set up this thing where we try to get Daniel to control things in my house from your house? And the whole thing was set up in under 90 minutes from deciding that that was what we wanted to do. So it came together incredibly easily. It was, and that was because from Michael's side and from my side, we'd already done the homework of putting all of the different pieces into place. And because at my end, pretty much everything is linked through MQTT, and the water cannon controller has support for MQTT, and my home automation system runs on it, I ended up just having to set up a little web interface running on a web server at Linode in California, and that web interface has buttons that can be used to control the lights and the water cannon. So basically all that happens is that when you click those buttons, it causes a message to be published to MQTT. That message is then picked up by Node-RED, and it then sends the appropriate command to whatever it needs to activate. So the whole thing was a little bit of PHP, some JavaScript, and a bit of Node-RED, and the whole thing came together. So the part of the system that I haven't really seen, and this is what I want to start talking to Michael about now, is how he is achieving some of this control of the cursor from his end and the various things that are being done. So being able to have control of a GUI, like some kind of a computer interface, is a really interesting problem. So in just a moment, we will... James, water cannon on. No, I haven't got it linked to the YouTube chat. At the moment, it is only linked to the... actually, I'm just going to... Oh, well, thank you very much, James and Frank, for those live chats. That's really generous. So I can see in the background, Michael is just getting himself back set up on his computer, and he'll be back on the stream in a minute. And then we are going to get to some questions, and I can see there are some really interesting questions here in relation to microphones and other things. And I'd be very interested to hear what Michael has experimented with, because what I could see just on the video then, he was using a standard microphone, like the sort of thing that you use with a mount that just sits on the bench, and then you have the microphone coming up in front of your mouth so that you can use it for, just on the computer. But things like microphone arrays could be really interesting as well. It could also be interesting to experiment with a microphone that is very directly connected. And this comes down to some of the experience that I've had with Chris and setting up microphones for him. So one of the issues with Chris's speech is that he doesn't have the ability to project very well. He can speak quite well, but it can be hard to hear. And so just simple amplification is a really important thing. So one of the things that Chris does is he has a microphone sitting just in front of him on the wheelchair, and that goes into a little mixer, and then that goes to an amplifier. The amplifier drives, actually it's been through a couple of different iterations, but originally it was a separate amplifier to a speaker, and the speaker was mounted up on the chair. And so it was basically like having a PA system attached to him constantly. And that has now been simplified a little. It now has a Bluetooth speaker, which has the amplifier built into it, and it's all battery powered. So it can be charged up and set up on the chair and attached first thing in the morning. So when Chris gets into the chair, the audio system is attached to the chair and turned on, and then it just runs for the whole day. And then it can be recharged at the end of the day or overnight. And so what that allows is for Chris's voice to be amplified, and it just makes it easier to talk to him when you're sitting at a normal distance of a couple of meters away, the usual sort of social distance, instead of having to get up quite close to hear. So in experimenting with that system, Chris has been through a number of different microphones, and one of the systems that we found works quite well is to take a little lavalier microphone like the one I'm wearing right now. I've got this one just attached to my shirt, and because Chris is wearing a ventilator, he has the mask across his nose. It leaves his mouth open, and there are straps that go around to hold the ventilator in place. So clipping the microphone directly onto the ventilator puts it very close to his mouth, and that tends to work quite well. So when we went to the Gold Coast in January for LinuxConf, that was the system that we usually used when he was out and moving about. So when he was at the conference and there's lots of background noise and people talking, which is basically the worst possible situation for trying to have clear communication, having the microphone clipped directly to the mask of his ventilator and picking up speech right near his mouth was what we found worked out the best. So it looks like Michael is back at his computer. So I will just add him back into the stream now. Michael, are you ready to go? Okay, fantastic. Hey, Michael.
Yeah, back in the stream now.
Yeah, great. So that was really cool to meet Daniel. Thanks for arranging to get him on the stream. That was really good.
Sure. Thank you so much, John, just for allowing Daniel to come on the stream as well. And we were just talking the night before. He was really excited to come on. He might have been a little bit nervous looking at the camera, but he was definitely thankful to have been given this opportunity, and so am I. So thank you so much for inviting us.
No, I love the work that you are doing. So this is really cool. So in the chat, there have been a couple of questions that have come up. Just while you were getting ready then, I was just talking about the microphones that we use with Chris and using a lavalier mic attached to his ventilator so that it can pick up voice speech right near his mouth.
Right.
And there was a question from Anthony Wakefield, who said to have a look at a 6-position sensor microphone, which could be used for voice input and processing, and a head-up screen, then send via Wi-Fi or Bluetooth or serial to a more powerful system. So there are a few things wrapped up in that comment or question. One is probably the first one is the choice of microphone. So it looked like you were using a standard desk type microphone just then for this video. Yes, that's right. Is that the one that you normally use on the wheelchair?
No, we use a wireless mic. That's from Samsung. And
Yep.
for that one, we use it because it's easier to wrap around Daniel's head when he's on the chair. I'm not too sure about the specs of the mic and how good it is, but we did it more for ease of access and so that it's closer to Daniel's mouth.
Ah, right. Yeah. So proximity is really important with microphones.
Yeah. And especially because it's a little bit soft, it's really important that we're able to kind of get rid of all the noise externally as possible and just get his voice going into the mic.
Yeah, cool. So one thing that I have been wanting to experiment with for a long time, and I just haven't got to it, is using microphone arrays to be able to do background noise cancellation. And this is something that I've thought could be really useful. And for some reason, Chris and I have talked about it a few times, but we've just never got around to experimenting with it. And so with a microphone array, you've probably seen this, but for the benefit of people who haven't, microphone arrays are typically used in voice assistants. And what you'll often find is that if you look at a typical voice assistant, like actually, I'm going to unplug mine and hold it up to the camera here. So here I've got an Alexa voice assistant, and if I get the angle right, there are these little holes all over the top of it. Each one of those holes is a separate microphone, and that forms an array.
Right.
So what happens is that if you are speaking coming in from a certain direction, the system knows that the sound arrived at the close microphone first, and then there was a slight delay before it got to the next microphone. And by doing audio processing, it can essentially become directional and ignore any sound that comes in from other directions. So you can be in a very noisy environment and focus the microphone on a specific point in space and ignore sound that comes from anywhere else. So that's the reason that voice assistants use that technology.
Right.
And you can buy microphone arrays from places like Seed Studio. I've actually got a few microphone arrays that I bought for using with the Mycroft voice assistant,
right.
and which is a fully open source DIY like voice assistant. And so I've been thinking for a long time that I really want to experiment with putting a microphone array on the tray on Chris's chair so that the array is directly in front of him, and have it set up so that it is ignoring sound that comes from anywhere except in the direction of his mouth. And then see if that is helpful in cutting out background noise. Because the problem with using something like a headset where you bring the microphone around, excuse me, and you're picking up the voice close to the mouth,
right.
What you're really relying on is relative volume. So you've got the volume of the voice being louder just because the microphone is so close to it, but it's still picking up all the background noise. And being able to eliminate that background noise, I think, would make a big difference. So, sorry, that was me on a monologue for a while. What I was really wanting to know out of this is, have you done any experimentation with different microphones or with microphone arrays to see if it is effective?
With microphones, no, not yet. Not with microphone arrays, which is a really good point that you bring up, because for Amazon Alexa, it must be really useful for having that microphone array to kind of isolate that noise signal. But for Daniel's system, we've just been using single mics, whether it's a mic like this or a headset mic, just to record his audio. Part of that was because I actually ended up spending a lot more time on the design, and so we kind of just found the mic to use and to put it on. But those are some really good points that you bring up with microphone arrays, and I think those should be better and more useful at isolating noise signals.
Yeah, it's one of those things that's been on my to-do list literally for years. I've been wanting to experiment with it, and I just haven't got to it. So, yeah, I'd love to hear experience of other people. And if people in the chat have experimented with this, I would love to know about it. Yeah, I know that there are people that have done really cool things, like sorry, I was thinking about something else for a moment. I do this thing where I'm thinking about a particular topic, and then I start thinking about other things that are related to it.
Oh my goodness, I do it all the time too.
Yeah, and then I try to do this decision: do I chase that squirrel or not? But I'm not going to chase that squirrel. All right. I think we've got a couple of other questions here. So from that same person, Anthony Wakefield, said the M5 stick uses a digital mic, and then he's provided a part number, and that might be something for me to check out afterwards. And also, David Rowe asked, can you please mention the keywords of the tech you use so I can do further research? Yeah, so if someone was wanting to learn a little bit more about this, what would they search for to learn more in terms of things like the machine learning system that you're using?
Yeah, so TensorFlow is a good place to start. So TensorFlow, and then just a speech recognition document about how speech recognition would work. If we're going into, let's say, the computer and how to control the computer, PyAuto GUI, so PyAuto GUI is
awesome.
Controlling.
I was wanting to ask you about that specific piece of the puzzle.
Yeah, sure.
Yeah. So does that run on Windows only, or does it run cross-platform?
No, it should run on Windows, Mac, Ubuntu, but it runs on Python. It's a Python script that you need to run for it. And there's a whole library and documentation revolving around PyAuto GUI, but essentially it will transform your screen into a 2D grid. And so your cursor, if you think about it, has an XY position anywhere it might be on the screen. And the Python library will track that position, and you're able to issue commands such as move it to a certain XY position, click, or you can also type keyboard commands as well. So let's say you want to search up something on YouTube. What someone might be able to do is use voice recognition to search that keyword up and be able to go to that video and click on it using this documentation.
That is really cool.
I might have tried for Daniel in the past.
Yeah. So it really gives you, I'm trying to think of an analogy. It basically gives you an abstraction layer on top of the user interface on the computer. So it then lets you drive that user interface in whatever way you like from your own code.
And it allows for full control as well of the system.
Yeah, that could be really handy. So just to explain a little bit for the audience how we set this up with the demo we did earlier, what I did was create a web page with a couple of buttons on it. And the buttons were lights on, lights off, and cannon up, cannon down. And when they are clicked in the browser, it would send the command that did all the things I explained earlier. And so from my point of view, all I had to do was create a web page with buttons in known locations. And then Michael could use his code to capture the locations of the buttons and then click on them from Python. So that was the little bit of magic that joined those two things together.
Yeah, we did that like yesterday in about like an hour or so, which is kind of crazy to think about because it's something big for Daniel. And to think that we could do something like that in under an hour with the tech we have right now is kind of crazy to think about. Yeah,
that's right. Yeah, I actually went and checked it. I was curious about how long it took as well. I went and checked the timestamps on our chat. And when I initially raised the idea with you, I was in the kitchen in my house. So I was sitting there in the kitchen with my phone, messaging you. And so the idea came to me and I just said, hey, how about we think about doing this? From that moment to the time when we said, we're all done, thanks, I'll see you tomorrow, was 90 minutes.
Oh, no way.
So
90 minutes is like an hour 30 to
yeah,
make all that happen.
yeah.
So I
And a
feel
fair bit of
work on your end, John.
yeah, but we didn't even start right away because we were just talking about whether it would be a good idea.
Right.
But from initial idea to all done was under 90 minutes.
Mm-hmm.
So that's pretty cool. When you got all those building blocks in place, you can link different things together.
For sure. Yeah.
Yeah. Now let me just have a look. The chat questions have scrolled off my screen, so I'm just going to have a quick look so that I make sure I haven't missed anything.
Mm-hmm.
And let's see.
It was really cool to see the robot arm move up and down. I think especially for Daniel as well, just to see that simple voice commands, he could do all that on the other side of the planet, which is just
yeah. When it's local, that's impressive enough. But when you're watching a live video of something you are controlling that is, literally on the other side of the world, that is very cool. James asked, did someone say that the voice recognition itself is roughly 3 seconds worth of the lag? But I don't think that was the 3 seconds. I think the 3 seconds was allowing for Daniel to take a breath. Is that right?
Yeah.
Like to say the wake word and then to issue the command after the wake word?
Yeah, so in Daniel's case, he'll say Ava and I'll recognize Ava. And then we usually give him about a second or two break in between before he says the next word, which is where the buffer comes from.
Yeah.
And it's because it's hard for him to say some consecutive words a bit different, a bit like in sequence. Other words, he's able to say it okay, but for the commands that we're issuing, he needs a bit of a break in between.
Yeah, cool. So just to get a feel for how effective the system is, in this example, we didn't use the wake word. So what you were doing was running a script that just immediately put it into listening mode so that he could say 1, for example, to turn the lights on. And so there's no delay in that. From the time that he says the word 1 to the time that you get an output from your system saying, I recognize the event and I need to take action, do you know how long that is?
So actually for this project that we did, what I did is I set a timer for it to listen to Daniel's voice instead, because we didn't have a lot of time to kind of implement everything together. So I ran a script where it would listen to Daniel's voice for about 3 to 5 seconds and record that time frame and then recognize that voice command and issue it as a Python command for the screen.
Ah, interesting. So it wasn't detecting that he had finished speaking.
Yeah.
It was just a fixed time period and then it would process it.
Yeah. So whenever Daniel was ready, I would press a button and then Daniel would speak the word and then it would recognize that word. Which is kind of how we were able to speak in between a lot. For voice recognition systems, a big concern is like all the words we speak in between, do we discard those words? Do we kind of keep those words for analysis as well? For this project, I did want to keep it a little bit simple for Daniel. Yeah.
Cool. All right, so let's have a quick look at other questions. And Pancake Legend, who is in the chat, that's Andrew from the local hackerspace, who's a mechanical genius, asked, was the party popper script involved? The short answer is no. For controlling the robot, what we were doing was taking a command from the party popper script was something that I used a while ago to trigger party poppers from events in the chat on my live stream. And that script was watching the live stream chat, whereas this time it's nothing to do with the YouTube chat. It was just taking button presses on the web page, sending an MQTT message, and then acting on the message. So this was actually in some ways a lot simpler than the party popper setup from back in July. Peter Lawler. Hey, Peter. Peter is a friend of mine from Tasmania. Said, I noticed the other day my new Intel NUC has a full microarray built in. I wonder if that may be a better platform to use. Lose GPIO, etc. by default, but gain far more processing. So there are a couple of interesting things that raises. Firstly, yeah, perhaps the NUC would be good because it has that microphone array. You could put the device directly in front of Daniel and then use its built-in microphone,
Right.
and then do the recognition on that. But as Peter points out, you lose the GPIOs. So you are at the moment using a Raspberry Pi with a microphone going into the Raspberry Pi, and then you are controlling the stepper motors to move the joystick. Are
Yes.
you controlling them from the Raspberry Pi GPIO to like motor drivers? Is that how it's all linked together?
Exactly. Yeah. So we're using 8 pins from the Raspberry Pi.
Yeah, cool. So if you went to something like an Intel NUC for the benefit of its processing power and microphone array, you would need some other system to be able to control the joystick. Like you would need something like an Arduino to move those and then send commands to the Arduino.
Yeah, we would
Yeah,
need an extra microcontroller for sure.
Yeah, that could be an alternative way to do it. Okay. All right. So, Millador asked, can you make use of the microphone in Alexa or Google Home? And James responded to that and said, the array pulled from another device only gives the hardware. Yes, one could salvage them, but would still be left with doing all the processing and software. Yeah, so if you're wanting to, there are really a couple of different parts of this puzzle, 2 different things that you need to solve. So I'm just going to I'm going to be searching for something while I'm talking here. So if you, for example, had an old Amazon, like an old Echo Dot or something like that, which has got a microphone array built into it, then you could pull it apart and use the microphone array, but you've still got to build the image processing software. Oh, not the image processing, the software that does it. So right. There's I'm just looking up some information so I can maybe put it in the
if you pick it out of
chat later.
Alexa, but I guess with the processing of the signal, we would have to do that a lot in software.
Yeah. Yeah. So the person I know who has the most expertise in all of this is a guy named Jan Schmidt, and his whole job is working on audio processing systems, and he does amazing work. So if there's anyone to ask about this, I think Jan would be the person to answer these questions. I might have to grab him and pull him, get some expertise extracted from his brain when I get to experimenting with this. Con K asked, could you use a smartphone to input voice commands since most decent phones have noise cancelling microphones to assist in noisy environments? Possibly. Do you have any opinion on that, Dan? Michael, have you worked with using smartphone input at all?
That's a really good point to bring up. To be honest, no, we haven't used any smartphone to try to interface with our current system.
Mm-hmm.
That is definitely a good point to bring up.
Yeah. I have a feeling that a lot of what goes on in a smartphone is also, well, the smartphones are an amazing combination of hardware and software, but I think a lot of it is actually software as well. It's not just a matter of physically placing a couple of microphones in the appropriate locations. It's far more than that. It's the digital signal processing that goes on with analyzing the audio that comes in and then removing audio that has echoes and other artifacts that indicate that it might come from further away. So, yeah, possibly if the smartphone was being used in its original hardware, so not trying to retrofit your own system into the hardware, but if you used a smartphone and it's onboard audio processing and just took its output, its audio stream output, that could possibly work. Like if you could generate an RTSP stream coming out of the phone,
Right.
that might work as well. But yeah, I personally think that if this was a problem, and also the thing is that we've just spent all of this time talking about microphones, and that may not even be the thing that actually needs the attention. If the microphones that you've got are working fine, then there is nothing to be gained by spending all of this time trying to figure out better microphone systems. So from your experience of working on this, which part of this whole system do you think is the most limiting at the moment? What is it that is a problem, or is everything working pretty smoothly?
I think there are definitely challenges that come up when talking about voice-controlled wheelchair or accessibility devices. For this project specifically, I think a big challenge that we had to go through, Daniel and I, was first learning how the heck we do voice recognition and technology behind that, because it's out there in the internet and it's out there to learn. But I think taking the time to learn that was a huge step. And I think the second biggest challenge is actually tinkering with the wheelchair itself. So for our case, we could only do the joystick because we didn't know a lot about the wheelchair electronics. And so going into it was a little bit of a challenge for us. But if we're able to have an environment where we could test wheelchairs, dig into the electronics and see what's there, then I feel like that's a really open opportunity and a really big avenue for progress to be made. So I think some of the limiting factors here are just the accessibility into the wheelchairs themselves and tinkering around with them, and technology behind voice recognition systems, which is out there. Just learning them might take a bit of time. It definitely took me a lot of time.
Yeah, cool. Well, I want to talk, there are a couple of other questions that we'll get back to, but I just want to pick on that point for a little bit. I'll stick on that point for a little bit. So you're talking about having a chair that you can experiment with and access to being able to control it.
Right.
So here in Australia, and this situation is different around the world. It depends on how medical services are set up. In Australia, what typically happens is that if a person has a need for a wheelchair, the funding for that often comes from a service called NDIS, which is the National Disability Insurance Scheme. And it provides funding for purchases, both one-off purchases like a wheelchair, and also for ongoing expenses like carers and everything else. So I've got no idea what the situation is like in Canada, but here in Australia, what happens is that if NDIS provides you with a wheelchair, technically they continue to own it. And then when you have finished with it, which could be, for example, the wheelchair has come to the end of its life, its batteries are stuffed, it's an old model, you need a new one, or needs have changed because the person who uses the chair has grown, so they need a physically bigger chair, whatever reason, in theory, that wheelchair should go back to NDIS because they still own it.
Right.
And so getting hold of, and also they're very expensive. So Chris's current chair cost 42,000 Australian dollars.
Wow.
And that, in terms of exchange rate, like Australian dollars and Canadian dollars, I think are not all that far off. So it's not like there's a big exchange rate difference there. It's somewhere in that ballpark in Canadian dollars as well.
I think that's my undergrad tuition.
Yeah. So the idea of getting hold of a chair that there are two issues. One is Daniel is dependent on his chair. So you can't just rip it apart and start modifying it and have it in a state where he can't use it. It needs to be functional and usable. So ideally you need a second chair that you can do experiments on. And if you damage the chair, like in Australia, for example, if we messed around with Chris's chair and we broke it in a serious way, then it's not his chair. So he could have some problems there. It's like, naughty, naughty, what were you doing to your chair? So So one of the things that you did just recently was you bought another wheelchair so that you could use it for experimentation.
Yes.
And that actually showed a very interesting thing, which is the changing technology in wheelchairs. So maybe explain how you went about getting another wheelchair.
For sure. Yeah. So yeah, with some really good points that John brought up, I couldn't just go into my brother's electronics because his usability of the wheelchair always comes first, and that's why the wheelchair was given to us. But to further progress this project of developing devices that can help people like him, I did want to continue on and work on a different wheelchair. And I'm not sure if they have it in Australia, but in Canada, we have things called Craigslist, eBay. I'm pretty sure eBay is there, but a lot of websites where a lot of reselling happens. And to get that wheelchair, I remember just going on like a couple of nights, just searching through, clicking through items, and I was able to find a really cheap wheelchair for about $1,000, comparing to the relative price of electric wheelchairs we have today, in a local place nearby. And I was able to contact the person, tell him about my situation, and he was able to negotiate down the price a little bit, because I still am a student as well.
Yes.
So we were able to get the wheelchair for $1,000, and it's essentially a bare bone wheelchair, no real electronics or tilting function. It's just two motors and the frame itself. But I did want to buy it because that's all I need to kind of start developing the next stage of my project, which is hopefully an autonomously driving wheelchair in the house.
Yeah, that would be great. There was actually a comment earlier in the chat, which is a throwback to something that Chris and I have been talking about for a long time, which is the idea of not directly driving a wheelchair in terms of saying, I want to go forward, left, right, because that's not really what you care about. What you care about is getting to your destination. Exactly. So being able to, for example, if Daniel could say, Ava, kitchen, and then the chair takes him to the kitchen, he doesn't need to care about saying left, right, forward, and moving down the passage. The chair should get him to that objective. Yeah. And I think ultimately that's really what we want to happen.
Mm-hmm. And even for Daniel as well, like because of his condition, I think it will get to a point where he isn't able to speak as he used to before. And
yes,
thinking about those times coming up, I think it's really important to have this kind of technology in place so that he can be as independent as he can be and move around the house as much as he wants as well. Yeah. Yeah.
Yeah, definitely. So I want to get back to the wheelchair in just a moment, the new wheelchair that you've bought. But first, I just want to get a feel for how much. So you're still studying, is that right?
Yes, I'm still in university studying my undergrad in engineering.
Yep. And that's a full-time course?
Sorry about that, John. I couldn't hear you.
Oh, sorry. So that's a full-time course?
It's a full-time course load, and I'm enrolled in engineering physics at the University of British Columbia. So we combine a bit of mechanical engineering, electrical engineering, and a bit of software as well. And it's kind of revolved around like robotics and a little bit of AI in a sense. So yeah, I think that's what really helped me find my passion for helping people with accessibility challenges and using technology and kind of tying them together in a sense.
Yeah. Well, that doesn't sound like an easy course load. There's a lot of difficult stuff in there.
The usual degree is 5 years. I'm extending mine to 6 years because I'm taking care of my brother as well, especially during this time of COVID. The care aides aren't able to come to our house, so I'm basically splitting my time between helping Daniel and taking my courses and working on this project that for him to use in the future. So I've decided to kind of take 1 extra year, but make sure that I'm focusing on all the things that I need to focus on.
Yeah, so you've reduced your workload for this period?
For this period, yeah.
Yeah, okay, cool. Yeah, where I was going to with this is that you have achieved an awful lot. The system that you have built is very impressive, and it must have taken quite a commitment of time. Now, obviously, there is very, very strong alignment with your study and the subjects that you're doing. So it's not like you were doing two totally unrelated things. Right. But still, this is a big thing to undertake when you're also studying full time. So yeah, I just wanted to say congratulations on what you've achieved. It's amazing to see what you've managed to do.
Yeah, no, thank you so much. I think there's still a lot of progress to be made on it, but I definitely do get a lot of determination from my brother as well. And I think he's the reason why I do things that I do.
Yeah. Okay, great. So just coming back to that wheelchair then. So one of the interesting things about the chair that you got, and so for background for viewers, when Michael and Daniel got this second chair for experimentation, we were chatting online about how to connect to the controller and how to start modifying it. And what we discovered is that the technology on this new, cheaper chair, in terms of its motor driver, is totally different to the motor drivers that are in the chair that Daniel normally uses. And so Daniel's existing chair is it's classic DC motor technology. It's a couple of big geared DC motors driving the two drive wheels, and then DC motor controllers in like an H-bridge configuration to drive them. And that is the same motor configuration as Chris's chair. And that's pretty much the way the major Western wheelchair companies do all of their design. It's come out of, if you look back at the history of the development of the current chairs, they really originate from 30 years ago with big lead acid batteries sitting in the bottom and 12-volt DC motors. It's very much automotive sort of technology. And then if you look at the new chair, so where this is getting to is that the new cheap chair that you got doesn't use DC motors. So the control system is totally different. So have you made any more progress with playing around with that chair, or what have you achieved since you've got it?
Yeah, for sure. I remember when we first got the chair and we took it apart, because for this chair, we're able to take it apart. And we looked on the inside. I believe it was DC brushless motors that were in the chair. And
yes.
Yeah, and the links that you sent were really helpful. So thank you for that, John. But afterwards, I was just able to kind of source a controller board for those DC brushless motors. Bought them off of Alibaba, and they should be arriving in a bit. But before, I got a cheaper one off of Amazon. I was able to control the motor by being able to control it moving forward and backwards. And for those brushless motors, it's a completely, not completely different, but a different interface for how we control those motors themselves. So it took a bit of time learning about that, but I was able to get direct control of the motors, which was a huge step, because instead of controlling the joystick, we're able to control the motors now, which is a lot safer as well when making a wheelchair drive by itself.
Yeah, that's really good. One of the so this is one of the differences in the conference talk that Chris and I did at the start of the year. We specifically talked about this changing technology where in China there has been the big e-bike boom, and the drive systems that are used in e-bikes and electric skateboards and all of these sorts of things are all using brushless DC motors, which are the same sort of motor as used in drones and all of those. So much motor technology now is moving towards this BLDC sort of arrangement, and the motor controllers are quite different. So what we're seeing is that the big traditional wheelchair manufacturers are still making chairs that have the old style DC motors, and the newer chairs, particularly coming out of China, are using this newer motor technology, largely driven by the e-bike boom, because e-bikes are being made in China in such huge quantities that things like access to the motor controllers, the motors, the battery packs, all of that technology is there ready to go. There are companies that make all of this stuff in vast quantities for e-bikes, and then to make an electric wheelchair, it's just a matter of taking two motors, two controllers, and sticking it on the chassis. So that control part of it is already taken care of, and they're not shackled to the history of development of the main incumbent wheelchair manufacturers, where they've got this history of making chairs in a certain way, and they keep iterating on that same design instead of starting from scratch. And the Chinese manufacturers have been in that position where they've been able to just start from scratch and go with the modern technology. So I found it really interesting when you got that chair and opened it up and discovered that it wasn't using regular DC motors.
Right.
That really just showed to me that this big gulf we've got at the moment between the traditional wheelchair manufacturers and the more innovative designs that are more efficient, more powerful, lower cost, etc., that are coming out of China now.
Right. Do you think it's partly because, like in the West, we've always like had these wheelchairs where we had DC motors, and we're so used to those motors that switching over might be a bit difficult, whereas in those Asian countries like China, they're trying out new things as well?
Yeah, I think that's very much it. It's a case of, if you are a company that is manufacturing a complex system like an electric wheelchair, there are a number of elements to it. There are the motors, there are the motor controllers, there is the logical controller that sends the commands to the motor controllers. There are all of these different systems. And so over time, typically the best thing to do is to iterate on your existing design. And there's a book from quite a few years ago now called The Innovator's Dilemma, which I think directly ties into this. And in The Innovator's Dilemma, it talks about the issue of incumbent technology companies being overtaken by upstarts, because even though the incumbent technology companies have all of the resources and they've got the existing customer base, in theory, they've got everything going for them, but those same things keep them locked into a linear development cycle where they are iterating on what they already have, and then they can be knocked off their perch by some upstart who doesn't have any of that baggage, and they can come in with a radical new approach that solves the problem in a different way and has some other advantage that the incumbent can't address, which could be performance, or it could be cost, or it could be a whole lot of different things.
Right.
But I think we are seeing that exact scenario play out right now in the wheelchair space. So yeah. Now, something I wanted to, I half asked you about this right early on in the live stream, and I just want to get back to it. In your house, do you have any other automation technology? Like, do you have Hue or LifeX lights or anything else around the house that you can control?
I think it mostly just related to Daniel's needs. So a big one was his computer, one was his wheelchair, and the lights as well. But other than those, there's not much other home automation equipment that we have. And Daniel spends most of his time in the room as well.
Yeah. Cool.
But, John, I know your house is like full of automation, which is super cool.
Yeah.
Yeah.
Yeah. Yeah, pretty much everything in my house is wired for control. Okay, so excuse me. So in relation to what we were just talking about with wheelchairs and new technology, Millador made a very good comment, which is that liability laws can be a factor as well. So yeah, I totally ignored that in my comment. And so one of the big issues, of course, is that Chinese manufacturers only have to comply with Chinese laws. US manufacturers have to comply with US laws, etc. And so if the regulation is tighter in one country, then that can inhibit innovation a little bit as well. So liability and insurance issues are a really big factor as well. Sorry, I'm just having a quick look at the chat because there are a few that I've missed quite a few. All right, so there is a comment that David Rowe did it, who is from a company called Rotec, did a talk about a system that he wrote called Codec 2, at LCA. So just for people that are interested in the whole audio noise cancelling sort of thing, if you want to go away and check this out later, there is a talk by David Rowe at LCA about doing microphone noise cancelling using codec 2. So that could be worth checking out. And Chris Holmes, a very old friend of mine. So in the chat, Christopher Holmes, who other people would be able to see in the chat, is, how long have we known each other, Chris? It must be 32, I think, or 33 years. It's something in that region. So Chris is a very old friend of mine. And in fact, he worked for me a long, long time ago. So we sort of lost touch over the years, but it's very cool to see Chris in the chat, reconnecting after all of these years. So Chris made the comment, I assume some frequency filtering would help as well. So so being able to cut out, being able to have a narrow bandpass filter where it removes any noise except the frequency range, which is used for speech,
yes, exactly.
would be part of a good strategy. Yeah.
Mm-hmm.
And Aaron Knox, who is a regular in the Discord and on chat, said, is there a reason why you could use an Alexa dot and use the Alexa, sorry, I'm kind of rephrasing the question as I'm reading it. Is there a reason why you could use an Alexa dot or input and use the Alexa speech API and custom Lambda skills? With the speech API, you can customize wake words and call words phrases and then run a custom Lambda script. So I think this comes back. I think the underlying problem here is in relation to wake words and the timing of utterances. So I think that would be the biggest thing you need to overcome, wouldn't it?
Yeah, and I think it's very it's different from every person. I think the way that it's set up for Daniel is it could be very different for another person. And I think how it's set up for Daniel is just specifically made for him. But if this was supposed to help another person, then I think we'd need a completely different timing or training of the neural network.
Yes. Yeah. So I think the issue with using, if there was a mechanism within the Alexa system where you could programmatically tell it to ignore pauses of a certain duration or ignore the first pause, then perhaps it would be able to do the job. But in your case, you've managed to achieve the end result with the system that you've built yourself. You haven't had to rely on any other services. You are 100% operating within the machine learning system that you've set up for yourself. So in some ways, that feels like you've made things hard for yourself because you've had to build the whole system. But in some ways, it also means that you have total flexibility. As you were building the system, is there anything that you felt that you missed that you would like you'd like to take advantage of existing speech systems, or did you not feel that there were any difficulties that you were making for yourself?
No, there are definitely a lot of difficulties in making like a specific voice controlled system. And I think a big part of it was figuring out how to do error handling when, let's say, we say a speech command and it's not recognized by the system itself. How to make that kind of difference, and how do we recognize if it's a word that the speech system has never really seen before in a way. And in that case, I feel like because Google and Alexa they have broad data sets, and they have multiple instances of how people utter words, and they have a huge and a deep data set which can be used to identify if someone has said something that might not be or is very close to a certain word. For Daniel's case, because we are very limited in the amount of words we have, it was kind of hard to work around that. What I had to do was just put a hard stop on these are the words that Daniel used, so just recognize these. Any other words, if it's less than, let's say, 80% recognizable, then we'll just automatically dismiss those words.
Okay, that's interesting. So yeah, I hadn't really thought about it that way, but having the much bigger corpus of words to work from in a system like Alexa means that they can also exclude things because they know that this word is not what you're
Exactly.
not what you're trying to match.
Yeah.
Oh, okay. Yeah, that's an interesting problem.
Mm-hmm.
Yeah. Okay. Yeah, cool. So our Pancake Legend asked, I wonder if voice-to-text dictation could help. Constantly monitor the entire text output for combinations of words. It's a hacky way to sidestep the wake word issues, but hacky is where we live. Yeah, so do you have... okay, this is a very interesting distinction as well. There is a difference between recognizing a word using a machine learning system like what you've got and doing speech to text. So I think when a lot of people think about speech recognition systems, in their minds, they conceptualize it as speech to text, as in you say a string of words and then you get a chunk of text coming out of it and then you process the text. But I think in your system, it doesn't work like that at all. It's not text that comes out of it. It is whether a certain word has been recognized and then taking action based on that. Is that correct?
Yeah. And I think even with the text to speech, like it would have to go through some audio processing to get that text out of the audio that's inputted.
Yeah. And also if you had in a classic speech to text system where you are generating an output, it gives you the ability to use context. So you can use rules where there are certain words, or you can look at the grammatical structure to decide whether a certain word has been recognized correctly. Whereas in your system, what you're doing is recognizing utterances in isolation.
Yeah.
And it's recognized or it's not, and that's it.
Yeah.
Yeah.
Exactly.
Okay, cool. Mike O'Connor, another Open Hardware Miniconf regular and regular in the chat, suggested LiDAR units indoor only are getting really cheap, under under $50. What? And ROS2 makes it really easy to get working. So LiDAR, and for those who haven't come across LiDAR before, it's like radar, but it uses light. So what it does is the way radar works is it sends out a radio signal and then you get a reflection back, and then the time it takes for that reflection to come back and various other things like frequency shift indicates Doppler shift and different things like that allow you to build an image of what's around you. LiDAR is like radar but using light. And because I think there are a couple of things that are really driving price down on LiDAR at the moment. One is the use of LiDAR for self-driving cars, and the other is the use of LiDAR for vacuum cleaners. And so many robot vacuum cleaners now have LiDAR on them so that they can map their environment, they can work around furniture and all of those sorts of things. So a couple of years ago, if you wanted a little LiDAR unit with a serial interface that you could build into your own robot, you would be up for many, many thousands of dollars. And now you can get them reasonably easily in the couple of $100 region. And Mike is now saying that they're $50. I haven't seen any that are down into the $50 region. That is really, really cheap.
Yeah.
Have you done anything with LiDAR, or have you experimented with that at all?
Yeah, it's a really good point to bring up. Just this summer, actually, I was playing around with LiDAR. There was a company in the United States called Robotis, and I sent them a quick email just about the project and where I wanted to take it. And they ended up sending one of their Turtlebot 3 autonomous robots for me to learn ROS and how to do mapping and localization from. So this
fantastic.
I was using a very small LiDAR unit. It's nothing too fancy, but just learning how LiDAR works and the applications we can use with that, such as SLAM, which is simultaneous localization and mapping, and creating maps and navigating around those maps. This past summer, I spent some time with LiDAR. He and I became
fantastic.
Yeah.
So do you have plans to do something like attach a unit to the wheelchair?
Yes, that's exactly where it's going to right now. I think for indoors in the house, LiDAR is pretty good. and
Mhm.
I hope to be able to integrate that into the wheelchair that I'm working on right now,
Mhm.
and get that rolling around the house.
Yeah. So that will allow you to do obstacle avoidance and, collision avoidance and that sort of thing.
And especially like
Yeah.
being careful about the walls and the turning radius as well.
Yes. Yeah. This is kind of chasing a squirrel, but I find it personally interesting, is one thing that I found interesting working with Chris's wheelchair is the geometry of the way that it's set up.
Mhm.
And to me, it's a little bit counterintuitive. With most wheelchairs, the drive wheels are in the center, and then it has front and back wheels for balance.
Right.
And it looks like Daniel's wheelchair is that configuration.
Yeah.
Is that correct?
Yes, exactly.
Yeah. And logically, that seems like the best thing to do for a chair because it means that you can rotate on the spot.
Mhm.
Wheelchairs don't have drive wheels and steering wheels like a car or something like that. They work on skid steer. So if you drive one wheel forward, the other wheel backwards, the chair just spins on the spot. And that gives you a lot of agility because it means you can do things like drive along a passage until you are beside a door and then rotate on the spot. So you just turn 90 degrees and then drive straight through the door. But one thing that I discovered working with Chris's chair is that the geometry is quite different. What he's got is drive wheels on the front and then dolly wheels on the back. So if you turn the wheelchair on the spot, the point of rotation is between the front wheels, which is at the front of the chair, which means the back swings around. And if he is nearby something, then when the back swings, it can bang into it. But the really interesting thing about this chair geometry is that it means you can get up alongside objects very closely, much more closely than you can with a center drive chair. Because what you can do is drive up to a wall, for example, so that say you're coming up to a wall and your front left wheel is getting very close to it. And then you swing the chair and the back will swing in and the chair itself ends up parallel to the wall and right up alongside it. And that sort of positioning is impossible to achieve in a chair with center drive wheels where it rotates on the spot because you have to allow for the swing on both the front and the back.
Yeah.
So the other chair that you've got, the new replacement chair, is that a center drive system or is it front drive?
It's actually a rear. So all
That's
the
rear drive.
at the back, and
Yep.
we have 2 dolly wheels at the front.
Yeah. Okay. So when it moves, if you turn a corner, the front swings wide as you go around the corner.
Yeah.
Yeah. Okay. So one of the in terms of setting up a control system for this, one of the things you have to take into consideration for as you're setting up ROS is the geometry of the chair and how it is going to track through the space as it does things like turn corners. And that could be very different for a front drive versus a center drive versus a rear drive chair.
Mm-hmm.
Yeah.
Yeah, those are really good points because I'm even noticing with this new chair and Daniel's old chair, the turning radiuses are so different, and it's even though it's like a small change in where the wheel positions are actually at, it makes a huge difference in terms of navigation and just self-autonomous driving. So those are some really good points.
Yeah. Okay.
Wonder,
sorry, I'm not even sure why I brought that up. It's just we're just talking about whatever. Peter Lawler just pointed out that Thayton is in the chat. So Thayton is Jan Schmidt. Earlier, I was talking about the guy I know who is an expert on audio processing.
Yes.
That is Jan Schmidt, and he is right here in the chat. So if there's anyone that knows about things like microphone arrays, it's Jan. So yeah, that's very cool that he's here. So Jan, I might be hitting you up sometime for spatial analysis on microphone arrays.
That would be amazing.
Yeah. And okay, so a question for you, Michael, from so Aaron Knox asked, is assistive tech industry the end goal for Michael? So where are you personally going with all of this?
Yeah, no, that's such a great question. Thank you for asking it.
I think just from going up with Daniel and what I've done for him with the wheelchair project, I found a lot of happiness with it, being able to help people with disabilities or accessibility challenges overcome what they have using technology. And I know that it's my dream to not only help Daniel, but a lot of other people in the world who face the same challenges. So I do see myself going into the accessibility space and tinkering around a lot in the lab, trying to think about new ideas, but
Yep.
ultimately to help people who are facing the same challenges. So,
Yeah.
yeah.
And was your career path dictated in some degree by this? If you had been an only child, would you have gone down this path? Is it your primary love, or is it really just a case of serendipitous two things work together?
Yeah, no, I definitely think that things aligned for a reason. If I was an only child when I was younger, I remember my parents, like I told my parents that I wanted to be the Prime Minister of Canada. But I think that when I first saw Daniel get his electric wheelchair, because I think I was in grade 2 at that time. He was older than me. But around that age, he started needing an electric wheelchair because he couldn't move his arms manually to push a manual wheelchair. And I just saw how drastically that changed Daniel's life for the better. And then throughout high school, as well as I saw him get other assistive technology that can be used to help him in his daily life, I realized that that was something that I wanted to do for other people. So going from high school to university, I chose engineering because of that reason.
Yeah. Oh, that's great. But engineering itself is something that you love as well. So for me personally, I find that it's really satisfying on multiple levels. Firstly, in relation to doing things that help other people. That in itself is a big thing. But even in isolation from that, I love doing engineering projects because of the problem-solving aspect of it as well. It's coming up against something that you haven't seen before, or trying to figure out how to make a voice control system when you've never actually built one before, and then solve a whole series of steps of puzzles to get to the end result. So I assume that you get that big buzz from working on these projects as well.
Mm-hmm. And like engineering projects, none of them actually like go the way you want to in the first step.
Yeah.
I've built a lot of circuits, and I've definitely made a lot of mistakes, but I think it's a really big learning process moving into the future.
Yeah. I think that's that's one thing that I have to be conscious of, is not holding on too tightly to my preferred solution to a problem. So trying to keep myself open to realizing that I'm trying to solve this problem, but perhaps there is a different way I could approach it, and it might make a whole lot of difficulties might go away if I just change my approach. So I think one of the most important mindsets to have in approaching engineering projects is seeing it as a series of steps, but not being totally fixed on the sequence, and being willing to step back. I mean, there's a project I've been working on for a while where, unfortunately, this is a commercial project that I'm under NDA for, so I can't go into detail. But I've personally just experienced this issue where I've been working on a project for a long time, and my brain was really focused on getting past a couple of hurdles, and it took a while for me to stop and think, I don't actually even need to overcome those hurdles, because if I approach it in a slightly different way, those problems just don't even exist. So sometimes you end up sort of chewing on something and trying to solve something when it doesn't need to be solved at all. And that's something that I personally have to keep consciously reminding myself. I keep asking myself, okay, I'm trying to solve this problem, but is this even the right problem to be solving? Right. And always be trying to solve the right problem.
Right. But I think finding that right problem takes a lot of time too. Oftentimes you gotta go through a lot of problems to find that right problem.
Yeah, that's right. So we are getting towards the end of our 2 hours. So I just wanted to put a call out to the audience. if there are questions that you have for Michael, please please drop them in the chat in the next few minutes, and we will get to them. So in the meantime, I would just like to highlight a couple of things. So in the description for this video, I put in a link to Michael and Daniel's YouTube channel. And this is a channel that they started just recently. So I think there are 3 videos up so far, and it is a channel called Just Two Korean Brothers. Is that right? Yeah. So there are 3 videos up there so far, and they are little snippets about days in the life of Michael and Daniel and things they get up to together. So please check the video description and you will see a link to their channel. So go and subscribe. And the other thing is there is also a link in the description to an article in UBC News about Michael's work. So if you're wanting to go and read a little bit more about this, please follow that link and check out that article as well, which I think may actually be the very first article that I read when Chris and I came across you and your work for the first time, and that was what prompted us to get in touch with you. Yeah, and so now that you have, all right, 2 related questions.
Yes.
Firstly, where can people find more about this and your project? Do you have anything published like on GitHub or a project blog, or is it really just those avenues that people can use?
I think for now, the project, I haven't published anything to GitHub yet because I wanted to make a little bit more of a complete version before I put it on there. But ultimately, the goal is to have it so that other people can use it as well in the future. In terms of the project, I think the best way to follow, well, first would be the articles just to get an intro, but then also I think I will be posting on my YouTube a bit more about the project and any updates that happen with it as well. And on that note, the YouTube page Daniel and I made because we've always wanted to share positivity and disability as well. Since I'm at home this semester helping Daniel, we thought it would be a good idea to share the positive moments that happen in our lives. Though editing takes a lot of time too.
I love the videos that you put up so far. They're kind of whimsical and fun. So yeah, they make me laugh when I've watched them. So they're very cool. And so that leads on to the other point, which is, do you intend to document, release, and make open source the things that you've done? Now, there are arguments for and against. And so I'm just curious to know what your plans are. Is this do you think it is a good idea to release this sort of thing as open source? Or there are problems with doing that as well? So I'd just like to know what your plans are.
Yeah, I'm a big believer in open source. I think the reason why we started this project was because we couldn't find anything on it before. And I think people in similar positions might benefit a lot from having this kind of technology being integrated into their lives. So at least for the wheelchair project itself, I do intend to make everything open source in the future so that other people can easily access it and use it for their home lives and their personal lives too.
Yep.
So yeah, that's the plan for now. And
okay.
Yeah.
So my perspective on that, which I've already talked about on this live stream, so I'm probably repeating myself, but it's that open source and assistive technology are like 2 things that go perfectly together, because assistive technology very much needs to be tuned to the needs of the individual. And it's really important to solve an individual person's problems, not to be trying to make a device that caters to, the 90% of the market. You want to be catering to one individual person, which means that it is ideal for taking existing projects that have been published or made available as open source and then tuning them to suit exactly what you need. So it's one of those situations where economies of scale don't play a part so much as they do in things like normal consumer electronics. It's a situation where taking a project and modifying it is really the best outcome. So I think open source for assistive technology is incredibly powerful.
Yeah.
And it enables people to solve problems or build devices where 80% or 90% of the work might have been done by someone already, but it doesn't really quite suit. So you just need to do the last little bit of adapting and modifying it to suit your own needs, and then you have something that is ideal. So I really like to see that. Yeah. So also a couple more things in the chat. Aaron Knox, who is always an incredibly generous supporter of Superhouse, has donated £99.99 and said, please share this with Michael. Not much in the grand scheme. Silly super chat limits. So he's basically contributed the most he could possibly contribute, but hopefully it can contribute towards kits and to prototype latest assistive tech advancements for Daniel. So thank you very much, Aaron. That's really generous. So Aaron has donated essentially £100, and I will transfer that over to Michael. So thanks, Aaron.
Yeah,
that is really, really nice.
Aaron, yeah, thank you so much for that.
Yeah. So, and Anthony Wakefield said, what are donations used for, John? So this is a follow-on from this. Normally what happens is that when people contribute using Super Chat on these live streams, that comes in as part of my advertising income, essentially. And then I use that for funding, working on projects and whatever else it is that I do for making videos. In this particular case, as Aaron has asked for this donation to go to Michael and Daniel, I will definitely be transferring that. And if anyone else wants to make contributions and note that it should be for Michael and Daniel, you can certainly do that, and I will transfer those funds to them.
Yeah, thank you so much. And all that fund will go to Daniel's wheelchair project and any accessibility projects that we have for him in the future. Thank you.
Yeah, that's great. So, well, we'll just stay on for another couple of minutes and wrap it up. But there was a question just from a little while ago. Milador asked, can you use your tongue to make a unique sound and use it as a wake word? Would be interesting to apply this. Would it be interesting to apply the settings of the ventilator for recognition? Now, there are a couple of things we can unpack from that question. Did you want to comment on that?
Yeah, I think with the clicking sound, it's definitely possible because you could detect like a sharp spike in noise from a quiet environment to, let's say, activate the voice recognition system after that initial click. With the ventilator, because I do know that the ventilator has that breathing in and out sound. We could also somehow tune it to recognize that, but it would be a lot harder, I think, than a click because it is a lower register for the breathing of the ventilator. But I think the click is a really good idea. Yeah,
that is. I hadn't thought of this, but this is really interesting because I think we could also get some output from the ventilator so that we can tell which part of the breathing cycle it's in. So the big problem with wake words with traditional voice recognition systems is you say the wake word, then you have the delay for the ventilator cycle, and then you can say another word. So perhaps what we could do is take data from the ventilator so that the voice recognition system knows that you have said the wake word, but the ventilator is stopping you from speaking. So don't time out while the ventilator is in that state. So basically disable the listening timeout in the portions of the breathing cycle where the person can't speak anyway, because it's not that they've stopped speaking, it's that the ventilator has prevented them from speaking.
Right.
So by linking those systems together, perhaps we could achieve some improvement in performance. I think that's a good suggestion. So thanks, Milador, for bringing that up.
On the ventilator note as well, Daniel, he does have a pattern of breathing on the ventilator where he breathes in the ventilator and uses that extra air to breathe out and speak at the same time. So that could definitely be something to be considered too.
Yeah, great. There's just been a contribution from my friend Andy. He just contributed Australian $128 towards accelerating Daniel's wheelchair hacking. So thanks, Andy.
No, thank you so much, Andy.
So yeah, I'll make sure these funds get transferred through. And also there was a comment earlier. James O'Gorman said at one point, this is referring to a live stream from a couple of months ago. At one point, I was trying to contribute to Unexpected Makers Fire Extinguisher Fund. Did you ever get one, Sion? So on that particular live stream, a couple of people put in funds to pay for Sion to get himself a fire extinguisher for his lab. And I did pass those funds on. So I'm not sure if he's actually ended up getting one yet, but he probably should. So, well, we've been on for a couple of hours, amazingly. When we started this, did you think we could just talk for 2 hours?
Honestly, these 2 hours went by a lot quicker than I thought they were. And I would really like to give props to Daniel as well for being on for as long as he could. We were just talking yesterday, and Daniel was like, I wasn't sure how long I could be on for because it is hard for him to continue to look at a screen, and he does need a break here and there. But I'd just like to say thank you so much for sticking with us as I helped Daniel kind of readjust in between, and just for being there to support Daniel as well. It means a lot to him.
Yeah, no worries. Well, I'm so glad that we could get you both on this live stream. This has been fantastic. And I'm sure we'll have you back on a future live stream. So if there is anyone in the audience who has other questions for Michael and Daniel or want to talk about assistive technology projects, one good place for that is the Superhouse Discord server. There is a channel dedicated to assistive technology projects. And so jump on Discord and ask questions and chat, and we can talk about wheelchair hacking and all sorts of other fun things. So, thanks to everyone in the audience for coming along. This has been a really fun conversation, and thank you very much, Michael and Daniel, for being part of this live stream. It's fantastic to see what you've managed to achieve, the system that you've built, and I really appreciate your time. So we're going to sign off, and I will see everyone next week. Thank you very much, Michael.
Thank you so much for allowing us to be here today, and thank you to everyone in the audience as well.
Yeah, thanks. Oh, one last minute thing. Anthony Wakefield just contributed $50 as well. So there's going to be some funds coming your way, Michael.
Thank you guys so much for all the funds, and I'll make sure to keep using them all for Daniel's project. 100%.
Okay.
Yeah.
Thanks. All right. Bye, everybody.